Welcome to The Explainer, everyone. I'm absolutely thrilled you're joining us today. Look, the UK is staring down one of the biggest infrastructure challenges in our entire history. We need to retrofit millions of drafty, aging homes to actually hit our net zero targets. It's a massive, massive undertaking. And if you've been eyeing the green economy, kind of wondering where exactly you might fit in to help solve this puzzle, well, you've found the right place. Today, we're taking a completely honest, no-nonsense look at transitioning into one of the absolute most vital roles in this whole push. We're stripping away the buzzwords, and we're looking at the pragmatic, boots-on-the-ground path of becoming a retrofit designer. Okay, let's dive into this. What does it actually take to upgrade the UK's housing stock? Because it sounds wonderful in theory, doesn't it? We all want warmer, greener homes that cost way less to run and have a tiny carbon footprint. But what's the actual on-the-ground reality of making that happen? I'll tell you right now, it is vastly more complex than just slapping some solar panels on a roof or swapping out an old boiler. Think about it. If you install an incredibly expensive heat pump on a house that has zero insulation and drafty windows, you haven't actually solved the problem. You're basically just generating clean energy to power a heating system that's working overtime to heat the street outside. Truly upgrading a home requires meticulous planning, a deep understanding of building physics, and serious technical expertise to make sure the entire system of the house works in perfect harmony. Section 1. The Retrofit Designer Role. Now, what's really interesting here is that we need to strip away the eco-glamour right now and just focus on the brass tacks. A retrofit designer isn't just some generic, vague sustainability position. It's a highly technical role. You are the central figure responsible for specifying exactly how various energy improvement measures work together, safely and effectively, in a specific property. It's essentially like a really complex, high-stakes puzzle. You have to make sure the pieces fit perfectly so the building performs exactly as it should, without causing any unintended harm. If you miscalculate the insulation thickness, or say you apply the wrong type of material to a breathable heritage wall, you aren't just making the house a bit chilly. You're risking major issues like thermal bridging or interstitial condensation, which is basically moisture trapped inside the very fabric of the walls. Your job is to engineer that puzzle perfectly so those risks are entirely wiped out. Section 2. The daily reality. Let's move on and see how this builds. And this brilliantly illustrates your concrete, day-to-day workflow. The process is highly sequential and demands just incredible attention to detail. First up, you're reviewing detailed surveys and assessment reports. And trust me, these aren't simple checkboxes. You're analyzing the vastly different realities of dealing with, say, a damp Victorian solid brick wall versus a poorly filled 1970s cavity wall. Second, based on all that data, you decide on the specific energy measures needed. Third, you're specifying the exact products and materials for the job, right down to the millimeter. And fourth, and this is absolutely crucial, checking for defects and risks. What's vital at this stage is constantly considering the delicate balance between ventilation and air tightness. You simply cannot completely seal a home up to keep the heat in without ensuring it can breathe properly. If you trap that moist, stale air inside, you're going to create severe, hazardous damp and mold issues for the people living there. That is the critical, unforgiving level of detail we're talking about. But of course, this job doesn't exist in a vacuum, right? You're not entirely behind a desk. It requires constant, on-the-fly adaptation. You have to really think through the installation sequences step by step. And as literally anyone who has ever worked with old UK buildings knows, site realities change the absolute minute you pull up a floorboard or knock on a wall or discover some hidden pipe leak that definitely wasn't on the original plans. When those surprises inevitably happen, and they will, you have to revise your designs quickly and safely. This means working incredibly closely like a true collaborative team with retrofit coordinators and the installers on site. The coordinator is particularly crucial here. They're basically your bridge between the theoretical paper designs and the actual tradespeople swinging the hammers. You rely on constant communication with them to ensure your carefully calculated design actually works in the messy real world. Section 3. The repetitive and the rewarding. So the crucial point is finding the balance between these two extremes. Because I promised you a completely honest, warts and all look at this career. On one hand, yes, you are going to face long periods of reading dense technical reports, staring at U-value spreadsheets, and digging through endless product literature. There's a lot of screen time, repeated standard checks to ensure strict regulatory compliance, and really careful document management. It absolutely can be repetitive. But on the flip side, the reward is massive. It's tangible. You are solving real, complex building problems the right way. You're the definitive firewall stopping poor quality retrofit work before it even happens. And ultimately, you're engineering homes that are genuinely warmer, healthier, and vastly more efficient for the families living in them. Pulling a family out of fuel poverty or curing a house of chronic black mold, that brings a deep, lasting satisfaction that makes all those spreadsheets entirely worth it. Section 4. Your technical stepping stones. We need a warm but very firm reality check right here, especially if you're looking to pivot your career. If you're coming from a general office background, jumping straight into full technical design work, it's rarely feasible. It just requires way too much specific, highly specialized knowledge. But please don't let that discourage you, because there is a very practical, highly achievable roadmap to get there. You might start by mastering retrofit basics just to understand the language. Then move into retrofit coordination to see how projects are actually managed. From there, maybe get involved in building surveying or pursue a recognized built environment qualification. Getting into surveying, for instance, is brilliant. It teaches you how to spot structural red flags like rising damp or degraded mortar, way before you ever attempt to design an energy upgrade for that property. These stepping stones build the crucial foundation of building science you absolutely need before taking on full liability and design responsibilities.
Section 5. How AI can help you.
As modern productivity intersects with traditional building workflows, we have to establish a really clear boundary. AI is an incredible, time-saving assistant for this role. It can do the heavy lifting by chewing through and summarizing those dense regulatory guidance documents, drafting your technical meeting notes, doing first-pass comparisons of products literature, and even creating handy design review checklists. It can even simplify complex technical wording so you can explain a plan clearly to a homeowner. However, and this is a big however, the ultimate building judgment, the design accountability, and the legal compliance responsibility, that must always remain with you. AI doesn't know the exact microclimate of a coastal property in Cornwall versus a high-rise in Manchester. AI cannot sign off on the structural and environmental safety of a family's home. You do. Your human expertise is the ultimate safeguard.
Everything we've covered in this explainer today is really just a taster. It's the tip of the iceberg. We've laid out the foundation, but the technical depth of building physics is vast, and so is the incredible impact you can have in this career. Transforming the nation's carbon footprint while fundamentally improving how people live, that is a challenge that requires dedicated, meticulous professionals.
If you want to take the next step and formally explore this, there is a direct way to take action right now. Visit LELAIL.com and simply say, "Start the Retrofit Designer Taster course." Doing that will unlock the full interactive course for you and allow you to earn your completion certificate inside LELAIL. So I want to leave you with this final provocative thought. Are you ready to embrace the technical rigor required to truly fix our homes? Do you have the patience to handle the meticulous, repetitive checks, knowing that the ultimate reward is a massive, tangible improvement to the way people live and the long-term health of our environment? It is a demanding, highly technical path, but arguably one of the absolute most deeply important ones we have right now. Thank you so much for joining me on The Explainer today. Think about it, and I'll see you next time.